Alright guys, so let's continue our discussion on Hadoop. So in case you're watching this video from YouTube, I'll suggest you to check the description box as well so that you can understand how can you get access to the program. Okay, now let's move on. Today we're going to talk about Hadoop 2 and 3 architecture. Okay, 2 and 3 architecture. Right, so we know that Hadoop 1 has a problem. And what is the problem? The major problems are: number one, name node is a single point of failure, right? Single point of failure. That's number one problem, right? Number two problem is only MapReduce jobs are supported, right? Are supported. And number three problem is your MapReduce also act as a resource negotiator, right? Which means it takes a lot of burden to process our job. Now this was the problem of Hadoop 1, right? And because of which in Hadoop 2 what happened, the entire structure were redesigned, and then we have a better approach of processing the big data now. Okay, now let me draw a diagram and we will understand with an example how the Hadoop 2 architecture would look like. Okay, so I'll talk with respect to Hadoop 2, and Hadoop 3 also follows the same architecture. You can also call it as a yarn architecture. Okay, so it's also popularly called as yarn architecture. Let's start with the diagram. Okay, so number one, I would like to say in Hadoop 2, right, whenever you start whenever you install Hadoop 2 in your system, what you see is you see name node, you see secondary name node. Okay, so you see node manager. Okay, you see a resource manager, and you see a data node. All right, so these are the demos which you see whenever you install Hadoop in your Hadoop 2 in your machine. It could be a single node, it could be a multi-node cluster, but on an average you would see basically these 5 services, right? In Hadoop 1, what we learned was we had name node, we had secondary name node, right? We had job tracker, right? We had task tracker, and we had a data node. So this is what we had in our Hadoop 1, right? Okay, so in Hadoop 1 we had this demos, right? In Hadoop 2 what happened is here few things are replaced. There is no job tracker and there is no task tracker. Okay, and the job tracker is basically replaced by your resource manager. Okay, job tracker is replaced by resource manager, and node manager is something like this, but then they have a different functionality itself, right? So what I'm trying to tell you is in your Hadoop 1.x you had job tracker and task tracker, you don't have them all together. Okay, and now all the work would be done by node manager and your resource manager. Okay, so let us try to understand these two things again. Okay, we will do the architecture again, and we'll try to understand how exactly the architecture would look like in a typical real-time Hadoop cluster that has Hadoop 2 and 3 in the production. Okay, now let's do what? Let's try to create a diagram like this. Okay, so I'll create a 3-node cluster, 1, 2, and 3. Okay, so let me create a 3-node cluster. These are the 3 slave machines. So this is slave 1, slave 2, and slave 3. Okay, so 3 slave computers, and then we will have one master here. Okay, a master and 3 slaves, and we will have some client here. Okay, so this is my client. So what is your client computer? In the real time, the client computers are basically edge nodes. Okay, so you can call it a edge node. And what is an edge node? Edge node is basically a machine which is not a part of your Hadoop cluster, but it has a connectivity with the Hadoop cluster, so that you can go ahead and do Hadoop fs-put and all those commands you can execute. You can submit some job and do whatever. You can write your hype queries and so on. So typically in a real time, when you work on a company, you basically get to see a Hadoop cluster, right, which you have no knowledge about, right, and you don't take care of it, right? So there would be admin folks, the DevOps team, who would basically manage this entire cluster for you, and all you will be given is access to this client node, access to this client machine, right? And since you are just using it, whatever command you write here would be converted into MapReduce job or Spark job or so on, and they would be submitted to this whole cluster. Okay, now these are basically called as your client, and you can have a lot of edge node in your production, a lot of edge node. Okay, maybe 4, 5, 6, 7 edge node, and these edge nodes would have a connectivity to all these clusters, right? So this is my client, and this is my whole Hadoop cluster. Okay, so I'll call it a Hadoop cluster. Now, when I say this is master, so as we know, let me write it down those resources again. Okay, so I'll just write it down here so that you understand. So we have name node, we have secondary name node, right? And if I talk about Hadoop 1, then we had job tracker, we had task tracker, and we had data node. Okay, this was Hadoop 1.x. Is not it? Now in Hadoop 2.x, what happened is a couple of things were replaced, right? So you have name node as it is. You can have secondary name node as it is. Instead of job tracker, you have a resource manager, okay, and then you have a data node as it is, right? So this is how it is replaced, is not it? So now I'm not going to talk about the name node and secondary name node in this whole architecture for now, okay, because my job is to understand in Hadoop 2 and 3 in Yarn architecture what is the difference it has actually brought, right? So this is basically your resource manager, okay, and then you have all these nodes, right? In all these nodes, what you have, these are the slave machines. So if they are slave machines, then it means it basically stores the data for you, which means data node, is not it? So you will have a data nodes here. Okay, data nodes are process. You'll have a data nodes here. And similarly, if you see, these are all node, right? See, resource manager, we understood this is the one, right? Now what is left? Node manager. So every node will have a node manager. Every node has a node manager. Now you may ask me, what is this node manager? So node manager is nothing but a process. Okay, when we install Hadoop in our system in the coming week, right? You will see that once you say your Hadoop is successfully installed, you just can list down all these things. You will just say JPS and you will see all of these are up and running. So these are basically the processes which basically goes up and running in your Hadoop environment. Okay, so these are basically running on your client machines, right? So the slave machines, right? So data node and node managers are basically installed. They are basically the processes which basically runs on your slave machines. Okay, now so we understood this, right? So now in the whole architecture, if you see, you have a resource manager. So this resource manager has actually two components. Okay, so resource manager, but this resource manager has two components. Okay, so number one, you have scheduler. Okay, number one, you have scheduler, and number two, you have application manager. Your resource manager has two components, scheduler and application manager, right? And then so whenever you say resource manager, it actually means you have two different components which basically would be hosted here. These are two different services. Okay, and then whenever there is any requirement, see, like when you want to store a data in a SDFS, right? So storing data in SDFS, you know how happens, right? So see, when I say master, in the real time, what you could also have is you could also have a name node here, right, and secondary name node here, but we are not actually highlighting that. Okay, so I'm not saying that they would not be there, but the only point is we're not really like worried about those because they are same what we saw in our Hadoop 1.x, is not it? Whenever you like upload the data, what happens? It goes to the name node, it looks into the metadata, and then it says, okay, it understands what exactly are the cluster details, where exactly the data can be stored, and then those informations would be transmitted back to your client, and then the client will start transferring the data. We already know it, so we're not actually talking about it right now here, right? So now our focus is on submitting the job. Okay, so we have resource manager which has scheduler and application manager. Okay, now suppose the client submits a job, right? So client submits a job. Now whenever client submits a job, to run a job you need some resources, right? So you need some resources. That allocation would be done by this guy, scheduler. Okay, so this scheduler, what does it do? It basically helps us to negotiate the resources so that the job can run successfully. For example, I have a job, let's say a MapReduce job, which I want to run, right? So what I did is I logged into this client machine and I said Hadoop jar and then wrote the command that can submit the job for me, right? So when you do that, what happens? This request goes to your resource manager. This request goes to your resource manager, and the resource manager says, okay, let me talk to scheduler, right? So what scheduler does, scheduler looks into the whole details of the Hadoop cluster, because it knows resource manager has all the information about the whole resources, right? If you look into this whole stuff, Now you can say this guy is the main, like king of the whole cluster, right? Because it knows how many nodes I have and what are the resources available, how much memory it has, and all those stuff. It has all the information with it, right? And then what it does is it basically says, okay, let me talk to the scheduler and let the scheduler identify all those places where this job could be executed, right? So now the scheduler will basically check with all the informations, and then it will say, okay, we have decided to run a job here and here, right? So the scheduler says 1 and 2 probably, let's say. Okay, so let's say the scheduler says, okay, you want to run this job, right? So this job we will be able to schedule it here and here, because I can see the data is also present in those machines and I have no problem scheduling that job in that place, right? Okay, done. So now similarly, if you have a typically a large cluster, then you can, the scheduler can say, okay, I would like to run this job in 1 2 3 and so on, right? So that's what the job is, that is what the job of your scheduler. Okay, so the scheduler will look into all the resources and it just negotiates. It just says, okay, I will reserve something for you so that you can get the job. Okay, so I'll also refer my notes so that I don't miss, because all these important topics are, all these topics are very important, and I really don't want to miss anything while we discuss. Okay, so it helps to allocate resource to the applications. They don't monitor the progress of the job. So this guy scheduler is not going to like monitor any progress. It will say, okay, I'll make something ready for you and consider it done, right? That's what your scheduler will do. Done. So the scheduler said, okay, I'll get it done for you. Then what happens? Then your resource manager takes the help of your application manager. Okay, so it takes the help of application manager and says, hey, we have to run one application because we got a requirement from a client. The client wants to submit a job, and I have already spoken to scheduler. Scheduler has already taken care of all the resources, how much memory would be needed on which machines and all. So all these things are taken care of. Now we must execute the job, right? So this application manager, what it does, it basically says, okay, we will do it for you, right? So then what happens is this application manager would basically launch a application master. Okay, so see here, we do not have a concept of application master so far here. So what it says, okay, we have to run this job, right? So what I'll do, I will basically get one container here, and I'll call it a application master. I'll call it a application master, and that application master is basically, I would say, a process which will monitor that entire application. There would be one application master for each application. And what is application? Each submitted job, right? So anytime you say Hadoop jar submit, right? So you fire that query. What it does is it creates an application master. And what is this application master? It is just a process which will help you to monitor the whole job, right? So this application master would take care of, this application master would be launched by your application manager, because we have to run the job, right? So these are all done by your resource manager. Now this application master is basically, I would say, just like your class monitor, right? So he's a monitor who will maintain the whole class, is not it? So now this application master needs what, this application master needs containers to run the job. The job cannot be executed without a container. So this application master says, okay, I need a container. I'll have 1 2 containers here. Probably I would have 1 2 containers probably here. And what is a container? A container is just a JVM, a virtual environment where you will have like a few codes, few memories allocated to do your task, right? So containers are basically the JVMs wherein the job would be executed. Okay, so this application master would basically get the containers, right? Get the containers, and then the job would be started in these containers. Okay, the job would be started in this container. So if you look into this example, I will have only one application master, and this application master would start the container probably here, probably here also, right? But then for one successful submission, there would be only one application master. Okay, there would be only one application master, and this guy would basically start running the jobs by launching the containers. And in these containers, you will have your map reduce job executing. So it is possible that map and reduce, something like this. Okay, so these containers can have map job, this container can have reduce job based on the requirement, and that's how your job would be submitted, right? So what we understood is, we understood that in Hadoop 2.x you have a concept of resource manager, you have a concept of scheduler and application manager, and then you have application master, and then you have a containers, right? So that's what the Hadoop 2 is all about, right? So in Hadoop 2 you have all these things. But now let us move forward and we'll try to understand, like the feature of all these things component by component. Okay, so we just understood a very high level. Give me a minute. So we just understood it at a very high level what exactly each of them does, right? But then let us try to pinpoint all these informations again. Okay, so I'll go through my notes so that I don't miss anything, because that's very important. So as we will just try to recap that also. So we have a master, which is basically a resource manager, right? And resource manager has a scheduler. And what is the job of the scheduler? It helps to allocate resources to the application. They don't monitor the progress and does not care about the job if they fail or not due to any errors, right? So your scheduler is not responsible to take care of anything. It says, you give me a work to do, I'll get some resources for you and I'm done, right? I don't really care about if the job is successful, if the job is progressing, if the job was cancelled, failed, or so on. That would not be taken care by your scheduler. Okay, what does it do? It basically I would say arranges the resources, and it does not monitor. Okay, so it does not monitor the job. So that's what your scheduler does for you. Now application manager, right? So now we are going to talk about this application manager, this guy. Okay, so it accepts job submission from the client. So that's what we have understood. This application manager would accept the job submission from the client, right? So see, it goes to the resource manager, but the resource manager has two components. The first component is scheduler, which does not accept any job. It basically will make the things ready, but then the job is actually accepted by whom? Application manager. Okay, so it launches application master for each job, right? So as I said, this application manager launches application master for each job, right? The moment you say Hadoop jar, it is actually a job, right? And that job is given to your application manager. What it has to do? It has to go and launch an application master, right? So it will launch an application master so that the job can be executed, and then it interacts with this application master on periodic basis to get the information about the job, how much job you have completed, right? Which means if I have if I submit 5 jobs, right, scheduler will arrange the resources for all these 5 jobs, and then this guy application manager would say, okay, I have 5 jobs to execute. Job number 1, I'll launch application master here. Job number 2, I'll launch application master here. Job number 3, I'll launch application master here. Job number 4, I'll launch application in some other master, and so on, right? So it is possible that one node can have multiple application master, right? Because it is not going to run only one job, right? In a real time, you'll have a lot of application master being launched in a single machine, right? So but remember one thing, that your application master is only one per application. Okay, so it is possible that the job failed due to some reason, right? And if that is the case, then your application manager will say, okay, the job failed here, let me try it here, probably, right? So I'll start application master again here. Okay, and let it again take the container, and do the process the job for you. So that's what your application manager does for you. Okay, so we understood application manager. I'll write it here. Application manager, what does it do? Number one, launches application master. Number 2, takes periodic update from application master. Number 3, relaunch job in case of failure. So that's what your application manager does for you. So I hope we are all clear with this, like resource manager, 2 things, scheduler and application manager. And I hope we understood what scheduler does and what application manager does. So this we understood resource manager. Now we are done with this resource manager. Now let's talk about this node manager, right? So as the name suggests, node manager means what? See here, every node has a process called node manager, is not it? So node manager is basically a service, right? A service which runs in every slave computer. This resource manager, as the name suggests, must know about the resources, right? How many nodes I have, and in each node, what is the total core, what is the total RAM available, right now, right? It's not like just how much is the total capacity. It should also know how much is available right now, so that it can schedule the job accordingly, right? Now this node manager is the guy, right, which will have all the information about its computer. Is not it? So it will have all this information, like currently what is the usage of a memory, how many cores are occupied, how many cores are available. The node manager will know everything about this, is not it? So the node manager would basically maintain the whole this complete node, one node, right? So this node manager will basically take track the information about this whole node, one node, right? And it passes that information to your resource manager, right? It says, hey, currently I maintain a node, right? And then currently in this node I have 20 GB of RAM available. I have 4 cores available. Others 4 cores are doing some other heavy job, right? So likewise, the node manager would basically give you the information. It gives the information back to the resource manager so that the resource manager will understand what the status of each node at any given time frame. It will also tell if I'm heavily loaded, right? If my health is not good, right? So it does all these checks and then it basically gives this information to the resource manager so that the resource manager will understand the status of a particular machine, right? This node manager would be installed on each node, right? And in each node, what you will see is you will see the containers, is not it? So whenever a container is initialized, right, it will take some CPU, it will take some memory and all those informations would be also available with your node manager, and these informations would definitely be passed to your resource manager so that it understands the situation, it understands the condition of a particular machine. Okay, so that's what your node manager does. We were talking about the node manager. What does it do? It basically monitors status of node, right, and reports to your resource manager. So that's what your node manager does for you. Now we will talk about application master, right? So if you see, this application master is basically, as I said, one per application. Okay, so as we know, the application manager launches this application master, right? And when it launches the application master, its job is to run the whole job. Okay, but then it knows that this guy scheduler has actually negotiated the resource, right? So what does it do? This application master in turn talks to this resource manager and says, hey, your scheduler has arranged some resources for me to run the job. Tell me what are those resources? Where do you want me to run that job, right? This guy would talk to this resource manager, says, your scheduler has negotiated something for me. Tell me that. It come like, and this information would be passed by the resource manager to the application master, right? And this application master now understands, okay, I have to run a job here and here. Okay, and accordingly it basically starts the container, right? So the container would be started, right? So the container would be started, and as I said, the containers are basically the JVMs, right? So they are basically the virtual environment wherein the job will run, and that is where the whole process would be executed. So it could be a Spark job, it could be a MapReduce job, anything, right? So that's how the container would be. So the container would be the container is basically a virtual machine wherein your job gets executed. We started the container. This container would start the job, but then all this job information would also be tracked by this application master, right? Because application master would be one for every job, right? So it has to understand what are the containers doing, is not it? Like, what is the progress of each container in throughout the cluster? In the real time, you will not see only 3 node cluster. You may see 100 node cluster, 200 node cluster, 10,000 node cluster as well, right? So it's the application master who would basically talk to all these guys and says, give me the information about the status, give me the status of what exactly you are doing, right? So all these informations would be maintained by this guy application master, and in turn that would also be given to the resource manager saying that, hey, our job is getting executed, we are actually holding this many resources, so that the resource manager will have a complete clue. I would also like to write about application master. What can it do? Launches container, okay, executes job, updates that to resource manager, right? So that's what your application master does for you, right? So this is what you have in Hadoop 2.x as well as in Hadoop 3.x. okay? So it's okay if you don't want to talk about the job tracker, task tracker, because as I said, these days nobody uses Hadoop 1.x, right? So it's okay to have the idea about Hadoop 2.x to understand more about Hadoop 2.x rather than talking about job tracker and task tracker. Okay, now in this whole process, now we want to understand what is the improvisation your Hadoop 2 and 3 has done with respect to Hadoop 1.x, right? Number one, if you remember, in Hadoop 1.x, you had you had a job tracker and task tracker, and job tracker was also single point of failure. Okay, but then we have now a resource manager here. Okay, we have a resource manager here, but then the question is resource manager a single point of failure? Before 2.4, your resource manager was also single point of failure, but right now the resource manager can be installed in many machines, out of which one would be made active, the other one would be standby. Anytime this machine goes down, then the other inactive machine can be brought back to the life, and then it can start resuming your job. And these things has to be configured in Zookeeper as well. Okay, and what is a Zookeeper? Zookeeper is just like your register, which can keep a lot of entries about your nodes. Okay, so that is where your resource manager can be made highly available. So that's one thing which I know everybody wanted to understand, right? Now the next question would be, what happened to this name node, right? Because we knew that in Hadoop 1.x, you said that the name node is a single point of failure. What has Hadoop 2 done for this, right? So is there any improvisation in name node with respect to Hadoop 2.x? Yes. Okay. So in name node, like Hadoop 2 says, I can have multiple name nodes. One can be active, the other one could be inactive. And then if at all one name node goes down, the other name node can take over that step. Okay, now in that case, see, there are multiple approaches to solve this problem. Okay, so I'll talk about one approach. If you have multiple name node, what they do, they basically, see, this is active name node, right? And as usual, you have fs image and edit logs. The edit log can also be like updated to your inactive name node, so that this is active node and this is inactive, but at the same time both of them should have the same copy of your edit logs. Okay, now in this case you can also have secondary name node doing the same job for you, but then there are other designs also wherein it says, hey, we don't even need your secondary name node, because now I will start maintaining two different name nodes, and I want this edit logs to be taken care in the name node, all this name node itself, so that I really don't even have to use a secondary name node, right? So that anytime the system restarts, this has the capability to like merge those together into a single fs image. Okay, so that's what basically these guys have done. But then, as I said, there are a lot of other techniques which many companies are following in a different way. Okay, and I just don't want to talk a lot about that because that will create a lot of confusion. For example, like there is also concept called journal node. Okay, when they say, hey, we will have one place where you keep updating our fs image, your fs image, so that anytime it like your name node is down, then it can just pull the fs image from us. But then they are designed concept. Few company would use that, few company would use this, but I just wanted you to understand a simple fundamental of Hadoop 2. And in Hadoop 2, what you have is, you have a highly available resource manager, you have a highly available name nodes, and as I said, if required, you do not even need a secondary name node. Okay, and then this could come and this could go. It does not really matter because they are all slave computers, right? So that's what we have in Hadoop 2 and 3 architecture. Okay, all right. So we understood this, and this is basically called as your Hadoop 2 architecture, right? Now in Hadoop 2 architecture, what is the problem we have solved? Let's try to understand that. Okay, so in Hadoop 1, as we know, in Hadoop 1 you had only MapReduce, right? A framework which is also a negotiator, and the biggest drawback was it is like accepting only MapReduce job, right? The Hadoop one used to accept only MapReduce job, right, and nothing else, and that was basically a bottleneck because people started building Spark and all of the stuff, and then Hadoop wanted to take it to the next level, saying that, hey, why should my framework support only MapReduce? Why can't it be replaced with some powerful engine, probably Spark, probably Tej, or anything else, probably Storm, right? And so what they did is they built a resource yarn, yet another resource negotiator, where it says, now we will not have a tightly coupled with MapReduce. Anybody who wants to use a Spark in my Hadoop environment should be able to configure it, or a Storm applications as well, right? So that's what we have in Hadoop 2. So it decoupled your MapReduce only in your whole Hadoop framework, right? And it has made it like a ad hoc, right? So it's like plug and play. If you want, you can configure MapReduce. If you want, you can configure Spark. If you want, you can configure anything else, right? So that's what it did. And now you're negotiating, right, and processing are all divided into scheduler, application manager, application masters, and so on, right? And then one more drawback I'll tell you about Hadoop one is, in Hadoop one you had a concept of map slot and reduce slot, okay? Wherein we used to say, in this machine, let me say I can have 4 map slot and I can have 4 reduce slot, for example, okay? Now in map slot, we used to have only map task, and in reduce slot, you can have only reduce task. But then in the real time, you may not need a lot of reduce task probably, but you'll need a lot of map task, okay? And that was the biggest problem in Hadoop 1. And then Hadoop 2 said, why not make it generic so that it can run anything? It could be map or it could be reduce. So it came up with the concept of container, and it said this would be a container, just a Java process, where it can run either map job, it can run a reduce job, or it can run any other Spark job or any other jobs, right? So that's what is basically given by your Hadoop tool. Now you may have a question, what would be a typical configuration of resource manager, name node, secondary name node, right? So see, all these are master computers, and remember one thing, all the master computers would be little expensive, okay? So they would be little powerful as well as they would be expensive, because they really don't want that to fail very, very frequently, is not it? So your name node, secondary name node, right, resource manager, they would have expensive hardwares, okay? Whereas your slave computers would be little cheaper hardware. When I say cheaper, it does not mean that INR 30,000 rupees, okay? So it does not mean that cheap, right? Because see, whatever is cheap for the company, it's not cheap for us, right? So it would still cost you a good money, okay? We were trying to work on a government project of some country. I cannot really tell about that. And we were just trying to do some cost estimation, right? We spoke to Cloudera. Cloudera said, for each node installation, I would charge 10,000 USD. Okay, only installation per node. So if I have to install, if I need to create a 10 node cluster, right? So let's say 10 node cluster, then I have to pay at least 100,000 USD. So that is what the Cloudera was actually charging, right? And it could be brought down a little bit, but then you don't expect that 10,000 USD would become 2,000 USD, and it's only software installation. Now you can think about how much money Cloudera kind of companies or any distribution companies are making. They are making a lot of money.